All right, guys, so today we're going to focus on graphing cotangent. The first thing we need to think about and remember is that cotangent, okay, is equal to x over y. So up until this point, we've been dealing with sine and cosine, or the reciprocals, which are x over r and y over r, or the reciprocals. So think about when we had x over r and y over r, remember that r was always the biggest. If you think back to the triangle, you had opposite over hypotenuse or adjacent over hypotenuse, and the hypotenuse is always the largest. So you were always getting a value between -1 and 1. Then when we took the reciprocal of those, you were always getting a value that was bigger than 1 or smaller than -1. Well, this is different now because we have x and y, and those values can be anything in relationship to each other. Okay, so let's go back and let's talk about the unit circle and look at some key values here. Okay, so if you think about cotangent, so if we take x over y, this would have been undefined. This would have been 0. This would have been undefined also. This would have been 0. And then it would have started over again. But think about it, undefined 0, undefined 0, undefined. So these also are going to repeat themselves, but they have some undefined spots. So we're going to have some asymptotes again. So I'm just going to give you a little preview here of what this looks like. So this is your graph of cotangent, and it's got a lot of asymptotes going on here. Okay? All right, so let's start to put some information together. So this is one of the key pieces that you need to remember. The period in this is different because look, it goes undefined a lot quicker, right? And it actually starts to repeat itself, quicker. So here your period is pi over b. Your quarters are pi over 4. Okay? And let's look at what these values would be. So if my period is, in this case, the b is just 1 technically. Okay, so my period in this case would just be pi. And when we divide that by 4, we get the pi over 4, just if you're wondering where those came from. So when we fill these values in, okay, I kind of started to do some values over here. I did the first value, which is going to be undefined. So we have a vertical asymptote. Okay, now pi over 2 I did as well. I got 0. And pi I did as well. That would be over here. That's where pi is located. And that was also undefined, so that would also be a vertical asymptote. Now, to do pi over 4 and 3 pi over 4, let's think about our 45, 45, 90 triangle. So cotangent, okay, instead of opposite over adjacent, is adjacent over opposite, so it would be 1 for pi over 4. Now, 3 pi over 4, okay, this pi over 4 is in quadrant 1. 3 pi over 4 is in quadrant 2, so it would be a -1. Okay, so let's take a look here. We have our vertical asymptote at 0. We have another vertical asymptote at pi. Now the key values that are important here for cotangent, like before for sine it was 0, 1, 0, -1, 0, and for cosine it was 1, 0, -1, 0, 1. So for cotangent, the key values are that you have vertical asymptotes on the end, and you have 1, 0, -1 in the middle. Okay, so now when you look at this, it kind of looks like a straight line, but this is a function, so we want to make sure that it hugs these asymptotes and it still kind of keeps its curve to it. So we got to come like so, okay? But you don't cross over those vertical asymptotes. Okay, now let's talk about domain and range. So in terms of our domain, we would say x cannot be, that first vertical asymptote is at 0 plus, now the next one's occurring where one full cycle goes through, so at pi. So pi k, the generic form would be whatever your period is, k. Okay? And then your range, if you look at this in terms of your y values, this is going on in the negative direction forever and in the positive, so this would be all reals for your range. Okay, let's look at an example that has transformation. So your period here, actually I'll do my vertical shift and all that first. So my vertical shift is still up 1. My horizontal shift is still going to be right pi. My amplitude is still 3. So a lot of this stuff still stays the same. Now for your period, you want to take pi divided by b, and my b is 2. So My period is pi over 2. My quarters, so I take my period divided by 4 still. So that would be, if I take pi over 2 divided by 4, I get pi over 8. Okay, so let's start our table here. So we're starting at pi because our horizontal shift, and we're counting by pi over 8. So that's technically 8 pi over 8. So this would be 9 pi over 8, 10 pi over 8, 11, and 12. And remember, for cotan, we start and end with vertical asymptotes, and then we have 1, 0, -1 in the middle here. So if we would put in 9 pi over 8 into this part, what we would get out from our trig function would be 1. So then times 3 plus 1, we would get 4. We would put in 10 pi over 8, what we get out of this would be 0. So that's all gone, so we just have the 1. And then we would get out a -1 times 3 plus 1, we would get -2. Okay, so let's set this up. We're counting by pi over 8, so I think I counted right there. So this is pi, so this would be 9 pi over 8, and sorry, this is so small. Okay, and okay, so at pi, we have a vertical asymptote, and at 12 pi over 8, and then at 9 pi over 8, we're up at 4, and then 1, and then -2. And you want to kind of keep it smooth, sorry I missed that one, and hug those asymptotes. All right, let's talk domain and range. So in terms of our domain, x cannot be my first vertical asymptotes at pi plus whatever your period is times k, because that's where the next one occurs at the end here. And we went one full period to get to that end. So plus my period is pi over 2. Okay. My range for this is always all reals. Okay. So your homework, you're going to have 2 cotan graphs, and then just to keep you sharp, 1 cosecant and 1 secant. I will post the answers to those as well. Have a good one, guys.